My name is Alexandra Jahn from the University of Colorado Boulder. I was asked to talk briefly about Arctic sea ice projections, in particular for the 2030s, when the next IPY will take place. To provide some context for those projections, let's first have a quick look at the observed Arctic sea ice decline over the last 46 years, since continuous satellite observations began. As you can see here, with the shift from dark blue to green colors, the Arctic sea ice has declined in all months of the year, with the largest decline at the end of the melt season in September. If we now compare the observations of Arctic sea ice extent to the output from climate models from the latest iteration of the Climate Model Intercomparison Project, CMOP6, we can see that the observations for the first decade of the 21st century fall largely within the simulated sea ice extent from multiple CMOP6 models. But we also see that there is a large spread in the simulated Arctic sea ice extent as shown by the gray shading, which is due to model differences. Now let's look at the CMOP6 projections for 2030s from these same models. Here I'm showing projections forced with the SSP2-4.5, a so-called middle-of-the-road emission scenario. However, in the 2030s, the emission scenario does not matter for the projection of Arctic sea ice. This only begins to matter after around 2045. We can see that the projected Arctic sea ice extent, shown here in the orange shading, is shifting to lower values than in the first decade of the 21st century during all months of the year. The largest change is again seen for the summer and early fall, August, September, and October, where the observed sea ice loss also was largest. In September, the CMOP6 models show a multi-model ensemble mean of 2.67 million square kilometers. But as the orange shading shows, the projection uncertainty is again large, reaching from close to zero sea ice to sea ice extents of 5.5 million square kilometers in September, which is higher than we had in recent years with around 4.3 million square kilometers. If we account for model biases, which tend to overestimate the September sea ice extent rather than underestimate it, the most likely sea ice extents for the 2030s can be expected around and below the ensemble mean, shown as a thick orange line here. To put this into context, I here also added the current record low sea ice extent in September from 2012, which reached 3.46 million square kilometer. This means that we can expect 2030 September sea ice extent to be between practically ice-free and the 2012 record low sea ice extent. We cannot predict what the sea ice during the IPY will be like exactly, even if the models were perfect, as sea ice is very variable even from year to year. Focusing on the lower bound in September for another minute, what is the probability that ice-free conditions could occur during the late summer of the IPY in the early 2030s? The CMOP6 models put the probability of ice-free conditions in a given year at 20 to 35% for the early 2030s. If you wonder how we could possibly get to practically ice-free conditions by 2030, given that it's already 2025, we actually looked at that in CMOP6 models and found that it is indeed a low probability event, but some model simulations do reach ice-free conditions relatively quickly from present day-like conditions, with the fastest one taking just 3 years. Finally, everything so far has been about the aerial sea ice coverage, but sea ice age, and along with that, sea ice thickness, because older ice is thicker ice, they have also declined over recent decades, as you can see here for sea ice age. The dark color indicates first-year ice, with all the other colors indicating so-called multi-year sea ice, which has survived at least one melt season. And we can see that the first-year ice fraction has increased over this time, whereas the multi-year ice fraction, in particular, the oldest ice older than 4 years, which is also the thickest ice, has declined. If we now look at projections, not from CMOP6 models, but from one model, the CSM1, we can see that towards the early 2030s, the first-year ice fraction is expected to continue to increase, and the multi-year ice fraction is expected to continue to decrease, reaching around 20% multi-year ice fraction in the early 2030s. Compared to the time of the last IPY, the observations together with the model projections suggest around a 50% reduction in the fraction of multi-year sea ice by the early 2030s when the next IPY takes place. To summarize, in the early 2030s when the next IPY will take place, we can expect a further reduction of Arctic sea ice area compared to today. These projections are independent of the emission scenario used, as scenario differences only begin to matter for sea ice projections after 2045. The projected changes are largest in the summer season, with a projected September multi-model ensemble mean sea ice extent of 2.67 million square kilometers for the 2030s. But there's a large uncertainty around that projection due to internal variability as well as model uncertainty. At the low end, we could have practically ice-free conditions in September. The models put that probability at 20 to 35% probability in a given year during the early 2030s. At the upper likely end, taking into account model biases, we are likely to be around or slightly below the 2012 sea ice conditions. The sea ice present in the Arctic during the next IPY is projected to have around 50% less multi-year sea ice than during the last IPY, with multi-year sea ice expected to make up only 20% of the wintertime sea ice. Thank you.